Hello, you're welcome to the third part of this video. But in this part, we'll be discussing how to find the inverse of a function. In part one, we saw the definition of one-to-one function, and we checked how to decide whether a function is one-to-one or not. And in part two, we saw a brief definition of inverse of a function. If a function is one-to-one, then we can talk about its inverse, right? So here we just want to see what are the steps required for us to obtain the inverse of a function. All right, here we'll be following 3 steps to do that. One of the first steps is that you write y as f of x. Step 2, you solve the equation for x in terms of y, if possible. And step 3, you interchange x and y. Then the resulting equation is y is equals to f inverse of x. So let's go straight to example 5. Now here there is a note here that step 2 and step 3 can be what? Reversed. So it means you can do 3 before you do step 2. It's still going to be the same. So let's solve this example. We want to find the inverse of the function. So the first step, according to my notes here, is that we write y as what? F of x. So it means you write y as what? 3x minus 2. So this is step 1. So step 2, what is step 2? Step 2 says we should solve for x in terms of y. This is step 2. So it means we can solving for x. You see that we have 3x is nothing but y plus 2. And this means that what? X is equals to y plus 2 over 3. Now step 3, we need to interchange x and y. So instead of x, it becomes y. And here, instead of y, it becomes x plus 2, everything over 3. So all we need to do is just take this y as our f inverse of x, which is equals to x plus 2 over 3. Okay. Now, if you want to check whether your answer is correct, but this is just for checking, you can use what we discussed earlier, which we call the cancellation property. We'll see the cancellation property. So you can check to see if f of f inverse of x equals to x, as well as f inverse of f of x. We discussed this in part 2 of this video series. Excuse me. So if we're able to check this, then we can check now if this is true. So let's check this one. What is f of f inverse of x? This is going to be f of f inverse is this one. So you put it in here, so which is x plus 2 of 3. And this is now, what is f of this? Look at f. F would multiply its input by 3 and subtract 2. So this will be 3 into x plus 2 over 3, everything minus what? Minus 2. This 3 will go with 3, so you will have x plus 2 minus 2, and this will give us what? X. So let's check the other one, which is, so we finished this, so this is true. So now let's check f inverse of what? F of x. This is going to be f inverse of f of x. What is f of x? F of x is 3x minus 2. So f inverse of this one, what is f inverse? Look at f inverse. F inverse, it will add 2 to its input and divide by 3. So this is going to be 3x minus 2 plus 2 divided by 3. So this is nothing but 3x divided by 3, which is equals to x. So in both cases, this cancellation property holds. So this is just to check. So it means that indeed this F inverse is correct, is the inverse of F. Now, example 6, we will do the same thing. Just take Y. We'll take Y equals to Y is equals to 2x plus 3 divided by x minus 1. So x is not equals to 1. So we can cross multiply because now we need to solve for x in terms of y. So, but now this is this 2x plus 3. This will give us xy minus y is equals to 2x plus 3. Then, since we want to solve for x, we can put the x's together. So this is xy minus 2x was going to be 3 plus y. Then we can factor out x. So this is y minus 2 equals to 3 plus what? Plus y. And now x here is nothing but 3 plus y divided by y minus 2. So all of this is what? Is step 2. Because here we are trying to solve for x in terms of y. And this one here is step 1. So the next step, which is step 3, is to interchange. So you write y is equals to 3 plus x over what? X minus 2. And then here, you can replace this y with f inverse of x equals to 3 plus what? You can write it as 3 plus x or x plus 3 is still the same. Here we have to put a condition. X cannot be equals to what? 2. So this is our f inverse. Because if x is equals to 2, you see that this will not be defined. So you have to put that restriction. As you can also see, we have that restriction in f. So this is how to find inverse of a rational function of this type. Now here you don't need to check. I mean, f inverse, so you don't always have to check. I just did this checking here just to let you know that but you can go ahead to do it, but it's not necessary. So example 7 is this one. You want to find f inverse of 4, given that f of x is 3x minus 4 minus 5. Now in this situation, what do you do? If you look at this y, you see this 4 to be your y. Okay, so this is y. And if you remember, I think in the first video, we have that of this, we said if f inverse of y is equals to x, this simply means that what? F of x is equals to y. Yes, we saw something like this. So we're going to use that same statement here. So this f inverse, because we're looking for f inverse of 4, we don't know what it is. So let's assume this f inverse of 4 is equals to x. So it means if we know what is x, then we know we have our answer. But what is the meaning of this? This will mean that what? This will mean that f of x is 4. And what is the meaning of this? What is f of x? F of x is this one. So this means that 3x minus 5 is equals to 4. So this simply means 3x is equals to 9, right? And this simply means x is equals to what? 3. But what is x? It means you can conclude that f inverse of 4 is equals to what? 3. Why did I say so? Because f inverse of 4 is equals to x, but x is equals to 3. So you can conclude this. Now, what is the other way you can solve this? The other way we can solve this is simply, we first of all look for what? The inverse. So you see the function is this one. So we can look for the inverse of this. So we take y to be 3x minus 5. And then we solve for x in terms of y. As you can see, x is just going to be y plus 5 divided by 3. Then you interchange. So y is going to be x plus 5 divided by 3. So after interchanging, then you remove y and just put f of x equals to what? X plus 5 divided by 3. And then we find f inverse of 4 is by substituting x to be 4. This will be 4 plus 5 divided by 3. So we have 9 divided by 3, which becomes what? 3. All right. So let's go to example 8. Very interesting question. It says that f of x is what? X squared plus 1, x greater equals to 0. So in this type of questions, you have to take note of this condition. Most of the times, the condition given is to make sure that your function is what? Is 1-to-1. Because if you look at this is x squared plus 1 is a parabola, open up, but it cannot be a what? 1-to-1, except you have this restriction, right? And here it's interesting to see that you still want to find what? We want to find the domain and the range of the inverse function. So let's study our function first. This function, we know that this function, if you can plot it easily, is easy to plot. This is x squared plus 1, so this is just open up, right? This is x squared, you shift it up. But if you look at this, this is not 1-to-1, but because of this restriction, it means you have to remove the right, we have to remove the left part, right? Because we want x to be greater than 0. So it's just going to be here upward, starting from 1. So this is actually the function f of x. So this is our f of x. And clearly you can see that this function will pass the horizontal line test. If you draw the horizontal line, it will only cut once. So it's 1-to-1. We can take it inverse. Now, here we want to find the domain. So we can actually find the domain even before we find the inverse. Remember, we said the domain of f inverse is equals to the range of f. So what is the range of f? From here, we can see the range is just from 1 to where? From 1 to infinity, right? From 1 to infinity. We can see this is the range. And we can see, because this is what? This is a parabola, open up. What is the vertex here? The vertex here is what? Is 0 and 1, yeah? H and K. So also we can find the range of what? F inverse, which is going to be the domain of f. And what is the domain of f? Domain of f is what is given is this condition here, because this condition is for f, and it's nothing but 0 to where? To infinity. So you can see we already have the domain of f inverse and the range of f inverse, even before we calculate the f inverse. But now let's go for the f inverse. For the f inverse, we write y is equals to what? X squared plus 1. We still have our condition, x is greater than or equals to 0. Now we solve for x in terms of y. You will see that x squared is nothing but y minus 1. So it means that if you take x, is going to be square root, but plus minus square root of y minus 1. This is very important. Okay? But because if you take the square root, this is x squared. If you take the square root, you're going to have plus minus. But because of this condition, x is greater or equals to 0. It means x is either positive or 0. It means we cannot take the negative 1, right? So since we cannot take the negative, we have to take x equals to what? Since what? X is greater or equals to 0. That is why we take the positive 1. Then what next? We interchange between y. So this is y is equals to root of x minus 1. And what is this y? It's nothing but f inverse of what? Of x, which is equals to x minus 1. And now you can see, you cannot just leave your answer like this, because even if you look at this function will not be defined for values maybe less than 1. Yes, because this is an even root. The inside here cannot be negative, so you need to put a condition, and it means x has to be greater equals to 1. How did I get this condition? 2 ways. You can get it from here after you find the f inverse. Since it's an even root, just set x minus 1 to be greater equals to 0. You'll get x greater equals to 1. Or you can actually use the fact from here. You can see already what is the domain of f inverse. The domain of f inverse is the range of f, which is 1 to infinity. So which is x greater than 1. So you can take it from here and just put it here. So this is the domain of what? Of f inverse. All right, so take notes. If you write just like this without the condition, your answer is incomplete. All right, so let's go to example 9. For example 9 also, we need to find the domain and the range. Also, we need to find the f inverse. So what to do is always good to study your f first. This is our f function. And as you see, this function is what? It's just it's a quadratic function. So, and don't forget that every quadratic function can be written as what? As a, why am I doing this? So that you can see that this function is 1-to-1. You can write it as what? A minus h squared plus k, right? Where h and k are the vertex. So you can find h and k, you can change it. This is in general form. You can change it to what? Standard form, right? So that it can be easy to visualize the graph. Now, to change it to standard form, you have 2 ways. It's either you use the what? Completing the square, or you use the formula for h and k. Remember, h is what? Minus b over 2a, I think. And k, you can find k by using f of h, right? Or you use, what's the formula? I think c minus b squared over maybe 4a or something. All right, yeah, or you can use any of this one. But I will prefer to use the completing the square. So this one, we call it what? Y. This is x squared plus what? Plus 4x. At this point, let me still call it f of x. Just want to rewrite. Completing the square, this will become x squared plus what? 4x plus half of the coefficient of x, which is the half is 2. When you square it is 4. So you add it, but you have to remove it also. So it will be like you're adding nothing, 0. But if we look at these 3 terms here, is equivalent to x plus 2 all square, then minus 4. So this becomes our function. Now, but we still have this condition, which is x less than equals to minus 2. Now, the beauty of this condition is that it helps you to visualize if actually the function is 1-to-1 or not. But if you look at this function, you want to graph it. It's easy to graph, right? You can graph it as what? Where is this is the h is what? Minus 2. K is what? Minus 4. So you're actually somewhere here, which is minus 2 and minus 4. And this is going to be what? An open up. Somehow, yeah, like this is going to be open up. Because why is it open up? Because the a, what is our a here is 1, right? The a is greater than 0. So now you can see the importance of this condition. This function on its own is not 1-to-1, but with this condition now, x less than equals to minus 2, it means we need only one part. So it means we have to go only this way. So clearly you can see that this function is what? Is 1-to-1. All right. Now that we've discussed the function, what does that mean? It means we can get the domain of this function. So let me use another pen here. So it means we can find the domain of F inverse, which is going to be the range of F. And what is the range of F? The range of F is just going to be from -4 to infinity, because this has a minimum. So if it has a minimum, the range will be from K to where? From K to infinity, right? And we can also find the range of F inverse, which is just the domain of F. But the domain of F is already given, which is this one here. This means minus infinity to what? To -2 close, right? Okay, we're good. So let's continue to find the inverse. Now, to find the inverse, what do? Follow the same 3 steps. We already have this one. So instead of f of x, we can just call it what? We can just call it y. And then we try to solve for what? For x in terms of y. To do that, you agree with me that I can write x plus 2 squared equals to y plus 4, right? Now with this, we need to solve for x. So it means that x plus 2 is equals to, since this is square, we're going to have plus minus, right? Okay. We're going to have this one. So it means that x is equals to what? I will take this minus here. So you have -2 plus minus. Please follow me. I'm still using plus minus. Now we have to decide, what should we use? Should we use minus, or we should use what? Plus. Because as you can see here, see, we still have what? We still have plus minus right now. So here you have to use the condition. What is the condition? X is less than equals to 2. So if x has to be less than equals to 2, it means we have to use what? We cannot use plus, because if you add you have -2. If you have x is equals to -2, if you add anything positive to -2, for example, if you add 1, it becomes -1, which is no longer less than -2. So for that reason, it means we have to take the negative one. So we have -2 minus root of y plus 4, since what? Since our x is less than equals to -2. So this now, what can we do? We just, we've solved for x in terms of y. This is the whole of this is step what? This is our step 2. And this is just step 1. So now we do step 3. We interchange. So y is equals to -2 minus x plus 4. So this is step 3. And here now you can replace this with f prime of x equals to -2 minus x plus 4. And also here, you cannot just leave it without a condition. So what should be our condition here? You can get the condition from here, which is x plus 4 has to be greater than 0, which means that x has to be greater or equals to where? -4. So this is actually the domain of what? Of F inverse, which we can get from here. We already got it from here. So you can just pick it from here. See? -4 to 8, which is actually the range of F. So this condition is very important. All right, next is example 10. So for example 10, we still need to find this function. Let's say this function. I like to visualize it. This function is nothing but what? Something like this. This is a root function, so it shifted, root x shifted 1 minute to the right. So we have something like this, but now it is reflected across the what? The y-axis. So it means we have to go down with it, right? So this is actually the graph of what? This is f of x equals to minus root x plus 1. So we can have like a minus 1 here. Yes. Now, clearly this is 1-to-1 because if you do the horizontal line test, it's cutting only once. So it is 1-to-1. Now, can we find the domain? We can find the domain, everything. Let's look for the domain of F inverse first. The domain of F inverse is what? It's going to be the range of F. And what is the range of F from here? You see, it's going to be minus infinity to where? To 0 close, because it's coming from down and going up at 0. So this is the range of F. Now, another way to find the range of F is what? You can find it directly without graphing. If you have a function, this is the function, f of x is what? Minus root of x plus 1. So what do we know about the roots? This is an even root, is always positive, non-negative. So if you this is always true. So if you multiply it by minus, so you have minus x plus 1 is less than equals to what? 0, right? Okay, so what does this mean? This means that what? This is our f of x. So our f of x is less than equals to 0. So it means it's from minus infinity to what? 0 close. So this is another way to find the range without graphing. Okay, or let me just do it here. This also, we can say that x plus 1 greater equals to 0 minus this less than equals to 0. This means f of x is less than equals to 0. So you have minus this. Okay. Now, let's look for the range of f inverse, which is equals to the domain of what? The domain of f. And now, what is the domain of f? Since this is f, the domain of f simply means x plus 1 has to be greater or equals to what? 0, which simply means that what? X is greater or equals to minus 1. So it means that we have what? Minus 1 to infinity. So this is the range of f inverse. Now let's find that f inverse. Y is minus root x plus 1. So solving for x. And here also, we should know that actually there is a condition here, but it's okay. What is that condition? That condition is the domain, even though it's not given. But we know that x has to be greater than what? Equals to minus 1. Because these even roots cannot be what? Cannot be negative, what we have inside. So now we solve for x in terms of y. We can square both sides. If you square both sides, this will just go. So this will just be x plus 1. And then x is what? Is y squared minus 1. Then we can interchange x and y so that you have y is x. Yes, y is x squared minus 1. So it means that f inverse of x is equals to what? X squared minus 1. Okay. All right, now we are here. If you leave your answer like this, it's still incomplete because you need a condition of what? On x. And what is that condition? That condition is the domain of F inverse. And what is the domain of F inverse here? You can see the domain of F inverse. We solve it in two ways. You can get it from the, we say it's the same thing as the range of F, which you can get from the graph of F, or you can use the analytical way to solve it, right? So, which is minus infinity to 0. Sorry, this 0 is close, huh? Okay, minus infinity to 0. So it means your X has to come from where? Remember, X has to come from minus infinity to 0, which is the domain of F inverse. In other words, you can just write it as X less than equals to what? 0. All right, so I think this is okay. We will take another short video for the graphs of the inverse function. So this, if you have any question on this, you can ask. And if you have not subscribed to my YouTube channel, kindly do that so that you can receive notification for other videos. Thank you for watching.